The future isn't waiting for permission to arrive. Right now, in labs and factories across the globe, technologies that sound like science fiction are already reshaping how we live, work, and think. These aren't distant dreams. They're the 15 tech trends actively transforming our world as we speak. And by 2027, they'll be impossible to ignore. Starting with something that's happening at a scale so small you'd need an electron microscope to see it. Sustainable nanotechnology. Scientists are manipulating matter at the atomic level to solve some of humanity's biggest challenges. In pilot projects across Asia and Europe, nanofiltration membranes are already pulling heavy metals and microplastics from water supplies with unprecedented efficiency. Hospitals are testing nanoparticle drug delivery systems that release medicine precisely where needed, sparing the rest of the body from unnecessary exposure. This isn't theoretical. It's happening right now, molecule by molecule. But while some innovations are getting smaller, others are reaching for the stars. Space-based manufacturing is turning zero gravity from a challenge into an advantage. When you remove Earth's gravitational pull, materials behave completely differently. Crystals grow more uniformly, metals form stronger bonds, and pharmaceutical compounds develop unique properties impossible to achieve on our planet. NASA and private companies have already conducted successful tests, with one firm returning space-crystallized drugs to Earth. The implications are staggering. Imagine semiconductors with perfect atomic structures or medicines that work more effectively because they were formed in the vacuum of space. Back on Earth, the industrial metaverse is revolutionizing how we design and operate factories. This has nothing to do with virtual reality games or digital avatars. Major manufacturers are creating exact digital replicas of their facilities where engineers can test equipment configurations, optimize workflows, and identify safety issues before implementing changes in the physical world. One major automotive manufacturer uses these virtual factories to plan assembly lines with dramatically reduced errors. When a digital adjustment proves successful, it can instantly update real factory settings through connected systems. The digital revolution extends beyond factory floors into the very structure of our economy. Web3 and decentralized systems are quietly building parallel financial infrastructures. While the hype has cooled, the technology continues evolving. European and Asian governments are testing blockchain systems for land registries and carbon credit tracking. Decentralized, autonomous organizations are managing community projects where members vote directly on budgets and decisions. Real estate tokenization allows people to own fractions of properties through blockchain records. These aren't replacements for traditional systems. They're alternatives offering transparency and new forms of shared ownership. Infrastructure itself is getting a digital makeover through digital twin technology. Entire cities are being mapped into virtual models that mirror real-world systems in real time. Singapore leads with one of the most comprehensive national digital twin projects, mapping everything from buildings to transportation networks. Airlines use digital twins to predict engine wear before it happens, reducing maintenance costs and preventing failures. Utility companies simulate power grid behavior during extreme weather events. These virtual models are already influencing billion-dollar infrastructure decisions worldwide. As artificial intelligence becomes embedded in critical systems, a new challenge emerges: understanding how AI makes decisions. Explainable AI addresses this head-on. When a hospital's diagnostic AI flags a potential tumor, doctors need to know why. When banks use automated systems to assess loan risk, regulators demand transparency. New frameworks break down the factors influencing each AI decision, transforming black boxes into glass boxes. Research teams across the US and EU are standardizing these explanations, making AI deployment safer and more accountable. The energy powering all these innovations is undergoing its own transformation. Clean energy has reached a tipping point where solar and wind are now the cheapest sources of new electricity in many regions. But generation is only part of the story. Countries are deploying massive battery storage systems to capture excess energy instead of wasting it. AI systems predict demand spikes and adjust distribution in real time. Ultra-high voltage transmission lines move renewable power across vast distances, connecting sunny deserts to cloudy cities thousands of miles away. Computing itself is evolving through the convergence of cloud and edge systems. Instead of choosing between processing data locally or in distant servers, modern systems do both simultaneously. Telecom companies are building edge data centers near population centers, enabling millisecond response times for autonomous vehicles and emergency services. Major tech companies offer hybrid platforms where quick decisions happen on your device while complex calculations occur in the cloud. This seamless blend makes real-time AI experiences possible at unprecedented scale. Biology and technology are merging in ways that would have seemed impossible a decade ago. Synthetic biology allows scientists to program living cells like computer code. Engineered microbes now produce biodegradable plastics and specialty chemicals. Pharmaceutical companies use modified yeast strains to create drug ingredients more sustainably than traditional methods. Government-supported biomanufacturing hubs are scaling these processes, transforming how we make everything from materials to medicines. As our world becomes more connected, it also becomes more vulnerable. Cyber-resilient security ecosystems represent the new frontier of digital defense. AI-powered systems continuously scan network behavior, identifying threats before they escalate. Machine learning adapts to new attack patterns faster than human analysts ever could. After high-profile ransomware attacks on critical infrastructure, the focus has shifted from just preventing breaches to ensuring systems can recover quickly when attacks inevitably occur. Education is experiencing its own AI revolution through ultra-personalized learning platforms. These systems adjust difficulty, pacing, and teaching methods based on each student's responses in real time. AI tutors provide step-by-step guidance without simply giving away answers. School districts are testing AI-powered dashboards that track individual strengths and weaknesses across subjects. Teachers gain data-driven insights to support each student more effectively than ever before possible. The very architecture of computing is changing through neuromorphic chips designed to mimic human brains. These processors use spiking neural networks that consume far less power than traditional chips while handling certain AI tasks. Major tech companies have demonstrated neuromorphic systems for robotics and edge devices where energy efficiency is crucial. Instead of brute force computing, these chips learn and adapt more naturally, opening new possibilities for intelligent devices. Even more revolutionary is photonic computing, which uses light instead of electricity. Light-based chips handle AI tasks at incredible speeds with minimal heat generation. Startups have already partnered with cloud providers to test photonic processors in data centers. Optical interconnects manage higher bandwidth with lower energy loss than traditional wiring. As AI's energy demands skyrocket, photonic computing could provide the breakthrough needed for sustainable scaling. AI itself is becoming more autonomous through agentic systems that don't just respond, they act. These AI agents can plan multi-step tasks, execute actions online, and adjust strategies when circumstances change. They're already booking travel, drafting documents, and managing schedules with minimal human oversight. In software development, agents write and test code automatically. While human supervision remains essential, the trajectory is clear. AI is transitioning from passive assistant to active participant. Perhaps the most ambitious project underway is the quantum internet. Multiple countries are building infrastructure for quantum communication networks using entangled photons to transmit information with absolute security. The U.S. has outlined plans for a nationwide quantum network connecting research facilities. China operates a quantum communication line between major cities with ongoing expansions. These early experiments lay groundwork for networks offering unprecedented security and entirely new sensing capabilities. These 15 trends aren't isolated developments, they're interconnected forces reshaping our technological landscape. From atoms to space stations, from quantum particles to global networks, innovation is accelerating at every scale. The question isn't whether these technologies will transform our world, it's how quickly we'll adapt to the changes they bring. That's it for today, folks. See you in the next video.